Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to pull Fred's chest plate off again and add to the Arduino Nano that's in behind it. This time we're adding in a voltage divider for battery monitoring. I'm looking at monitoring 4 different battery voltages, and while I'm at it I'm going to add a I2C plug on there so I can connect up other I2C devices, such as potentially a OLED, organic LED display, and maybe add in a MPU6050 in behind the chest plate mounted to the chassis. So let's get into it. Okay, so now that I've got that out, I've got all that hot melt glue to free up. So we'll do that, and then I'll be able to put in my resistor networks and set up the plug for the I2C. Okay, so there's 2 things we need to connect up. One's the I2C plug. The I2C plug will consist of a ground wire, VCC, or 5 volt in this case. There's also going to be the SCL and the SDA, so that's 4 pins. So we'll solder a header on up this end, and that will be good for the I2C. Now for the battery voltage monitoring, we're going to connect on another 4-pin header, plug that on here, and then we're going to create a resistor network. Now the resistor network is quite straightforward. It consists of 2 resistors, a 10k ohm and a 56k ohm. By hooking the 2 resistors in series, we get a total of approximately 66k ohm resistance from one end of to the other. We connect one end to ground, the 10k resistor, the other side we connect to ground, and then the 56k resistor can connect to the battery voltage. Now, because the batteries in Fred are around about the 20 volt level, it's far too high to connect that directly to an analog input on the Arduino. The maximum we can connect to an Arduino analog input is 5 volt. If we exceed that 5 volt, we are going to blow it up. So by using this divider network, we should get less than 5 volt at 20 volt, where the junction is. So in theory, if you've got 5 volt at the junction, there should be about 33 volt at the top end pin based on that divider network. So that gives us plenty of headroom in case of a higher voltage. Now, the switch mode power supplies like the one I've used for the Raspberry Pis, a 3 amp buck boost module, have a maximum input voltage of 30 volts. So we shouldn't come anywhere near going over that anyway without doing other damage. So I'm going to wire all that up now. Now I know somebody's going to notice that the resistors are not all in line with the header that I've just soldered on. And the reason for that is the header that hasn't got a resistor on it is going to be a ground, because I'm going to grab one of the voltages I'm monitoring from the switch mode power supply feed, and the other three will come from the other side of the robot chassis, each of the power sources. So the one from the switch mode power supply will come in on this connection that hasn't got a header connection on it. So I'm just doing the high side resistor, the 56k resistor first. And you may have noticed that I've put the second wire to a different strip for each resistor. Okay, so that's all wired up now. Next trick is to install it back into the chest so that I can plug the connectors in there. Now there's been issues with the MPU6050 Inertial Measurement Unit. For some reason it's not working when connected to the Raspberry Pi under the Nixie system, the Nixie version of my Robot Lab, but it is working under the Manticore, the older version of my Robot Lab, working directly off the Raspberry Pi. Now, one of the developers has tested the MPU6050 via an Arduino connected to a Raspberry Pi, and it is working. So I'm going to try that here, connecting it to that new I2C port I just soldered in, and make sure it works. The port was wired up so that I can plug something else in as well down the track. But the 4 pins here is to be connected eventually through to the back of the robot for battery voltage monitoring of the 2 batteries on the back independently, and potentially of a power supply source. I'll get some power diodes in as well and use those for protection, make sure things don't go bang. And I also want to set up some power diodes with one or more of the batteries connected through the key switch to keep the computer power on. So if a battery fails, as in goes flat, the controller will still have power coming from the secondary battery and can actually notify the program, which can notify the operator that it needs a new battery. So let's mount this back in place. Okay, I noticed when I was pulling it out, there was a lot of undue stress on some pins, which made it difficult to get it in and out. The pins were required when all these parts were separate parts, and one of them came from here and broke off while I was pulling it out. So to help prevent that from happening again, I'm just going to remove the pin on the other side. And it shouldn't get in the way then, and it shouldn't be an excessive load. So that's all put back together now. Because this is really only a temporary install, I've mounted the MPU on this plate and the chest plate. It should be reasonably stable where it is. Shouldn't move too far, but it should be able to be removed when I want to. So let's put this back into the robot, or back onto the robot, and we can power it up and see if the MPU works through there. I'll have to do a little bit of configuration to set the second one up to use it, but it should all be good. Okay, let's change. Okay, so that's Fred all plugged back in. Panels are back on, and I've just powered him up. And that was... I haven't hooked power for the Arduino yet. So we can see the NeoPixel is starting to light up. So the next trick will be to see how my robot lab is responding to it. For that I have to log into it, assuming it's connected to the internet already, or the network. Okay, so now that I've got that back up and running, let's have a look and see how things are working now. Before I do launch my robot lab, we need to get into its configuration and add in that second MPU6050. Okay, one more file to change. Okay, save that. Right, so I have an error in the code. Right, so that's set back in the configuration file. Okay, so when running in my robot lab, particularly under Linux, case is important. So a lowercase b is different to an uppercase b from the program perspective. So we'll restart this. So it's loading language files for the Mary speech service. The NeoPixels have started up. And the ultrasonics are responding. So let's have a look and see what we've got in the MPUs. So we're reading all zeros there at the moment. We do a refresh. We can see we're getting 36.53. This is from MPU6050A. This is the one that's in the head. Acceleration on X is minus 1.688. I do another refresh, everything goes back to 0. We've still got 36.53 degrees and everything else is at 0. Looking at the B1 in the chest that we just installed, we have an X acceleration of 0.017 G, minus 0.038 G, and in the Z 1.076, which is in the ballpark of being valid. 24.53 degrees C on the chip itself is valid, although it's minus 2 degrees per second on the gyro. It's reading a bit high, but I've seen that in Manticore. I think it's just a calibration error. It looks more like arc seconds than degrees. A refresh has still got us in the realm of reasonable sort of values. So this is the MPU6050 working through the Arduino, and this is the MPU6050 working through the Raspberry Pi interface. So we have got a bug there, and that's one that we've been working through with the guys at My Robot Lab. So I can now report back to them that it does work through the Arduino and not through the Raspberry Pi using the same code. Now what I haven't done is look at any of the voltages coming back on that Arduino, and that's something I'll have to do after I finish writing the code for it. So I will call that it for this video. Don't forget to click on like, subscribe, ring that notification bell. There's a link in the description to the Discord server where you can ask questions. I have a Patreon account. I'd like to thank my #1 Patreon, Go Lucky, and my new Patreon, Lewis. There will be a link in the description for that as well. And we'll see you in the next video.